I'm Anil Kumar. Let me thank all the members of our free Math Solutions WhatsApp group for participating so actively. So many of you are posting questions and many of you are providing excellent solutions. Now here is a question based on geometry which I like to address here, which I've written in short and we'll discuss it now. The question is that diagonals of an isosceles trapezoid bisect angle if the three sides are equal. Let me make a sketch. I'll make a rough freehand sketch here. I hope it will serve the purpose. So we have a isosceles trapezoid, which basically means that the opposite sides, one set is congruent, the other side is parallel. Right, so that is what is an isosceles trapezoid. Now in the question, we need to prove two things. One of them is that the diagonals of the isosceles trapezoid bisect angles. So if the three sides are equal, we are also given that this side is also equal to those two sides, right? So that is also given. So these three sides are equal. And we need to prove that if I draw this diagonal, then it bisects the angle here. So we need to prove that these two angles are congruent, right? And same should be the case for the other diagonal also, right? So if I join the other diagonal, in that case also we want to show that these two angles are congruent, right? So these two angles are equal. So that is the question. We'll actually need two theorems which are based on trapezoids. I'll actually provide proof of those things in my solution. So let us say this trapezoid is ABCD. Now in this particular case, since we have AB which is parallel to DC, and we are also given that AD is equal to BC and is also equal to DC. So all these three sides are equal, right? Now that is given to us. Now if you look into this parallel, then this angle, let us say this angle is 1, then this angle 1 should be equal to the angle 1 here. These two angles should be equal since they are alternate angles, right? So we have angle ABD is equal to angle BDC, right? Alternate interior angles. Right. Now you also observe that triangle DBC right here is an isosceles triangle. Since we know that DC is equal to CB. So two sides are equal. Now since it is an isosceles triangle, then angle DBC should be equal to BDC. So both are equal to 1. Do you see that? So from this isosceles triangle itself, we know that these two angles are equal, and from the parallel sides and this transverse interior angles, we know these two are equal. Therefore, we know that the angle ABD and DBC are same, right? So that implies that diagonal DB bisects angle ABC. Is that clear to you? So that is the first part. The second part of this question was, let me add that, the second part which we need to prove is that the diagonals AC is congruent to triangle DB. Right? So we also have to show that these two are congruent. Well, that can be easily done by proving the triangle ADC and triangle BCD as congruent. Can you tell me how? Well, we have a common side, right? So we have a common side here. So this is because of SAS. We have a common side DC, which is equal to DC, right? This is a common side. And we have AD equals to BC. And the third thing is that this angle, which is ADC, is also congruent to angle BCD. Now this is a theorem which is valid for all trapezoids. So that's a theorem. Theorem states that base angles of an isosceles trapezoid are equal. So from that theorem, we know that these two angles are equal, right? So these two angles here are equal. And therefore, those triangles are congruent. Perfect. Now, once the triangles are congruent, we know that AC, which is part of one triangle, is congruent to DB, which is part of the other triangle. Is that clear to you, right? So that is how you get both the parts of your question. Now, proof for this, I can attach at the end of the video. You can look into the proof. I'll just attach it along so that you understand the proof also. So I hope that helps. Once again, let me thank you all in participating so actively and giving me an opportunity. All those who like to get solutions to their problems can always join. I will provide you a link of our WhatsApp group in the YouTube channel. We'll discuss two very important theorems, the proof of these theorems based on isosceles trapezoid. We'll also take a few questions where these theorems will be utilized. So the two theorems are the base angles of an isosceles trapezoid are congruent and diagonals of an isosceles trapezoid are congruent. So let's talk about the isosceles trapezoid. It is a quadrilateral, as you know, which has one set of parallel sides, right? So it has one set of parallel sides. Let's say these are the parallel sides. And when we say isosceles trapezoid, we mean these two sides are congruent, right? So they are equal. So we're talking about these kinds of trapezoids, and in such trapezoids, the base angles are congruent. That is to say that we need to show that the angles, we may say these angles, or let me just say those angles are congruent, right? So these angles are congruent. This is what we need to prove. And then in part 2, we will take up that the diagonals of the isosceles trapezoid are also congruent. That means from here to there and this to this. These diagonals are also congruent. So let's label this. Let us say the trapezoid is ABCD. So we are given here that AB is parallel to DC. We are also given that AD is congruent to BC, right? So these two sides are equal. So that is given to us. Now, to prove, we need to do a little bit of construction. So let's do construction. We'll actually draw a line parallel to AD from B, joining DC. So let us say this line is constructed so that this line is parallel to AD. So here we'll construct let's call this as E. So construct BE parallel to AD. So these two lines are parallel. So what we get here basically is that AB, ED, this quadrilateral is a parallelogram. Correct? Since we have constructed, since from construction. We have AB as parallel, right, given, and then these two are parallel and the opposite ends are parallel. So from the first two, above two statements. Now when they are parallelogram, then what we can also see here, that since these two are parallel sides of a parallelogram, AD should be equal to BE, right? So that side should be also equal. So we get BE as equal to AD. But since AD is equals to BC, so that implies that BE is also equals to BC. Well, that is a transitive property, right? So these two are congruent. Now if two sides of a triangle so are congruent, then the triangle BEC will be an isosceles triangle, right? Now this is an isosceles triangle, and therefore we have that the angle which is BEC should be equal to angle BCE, correct? So these should be equal angles. Right? Now, because it is an isosceles triangle. Now, what we also know is that these are parallel sides. So the angle ADE, we can say ADC, is also equal to angle BEC. But earlier we have shown that BEC is equal to angle BCD, right? I am combining two statements here. Well, these two is because of corresponding angles. These are parallel sides, right? So these are corresponding angles. And this here is because of the transitive property. Correct? So when you're giving the proof, you can actually work out the details, right? So what we have come to is that this angle is also equal. So all the three angles here are congruent. Well, we have already shown that two base angles are congruent. Do you see that part, right? Now, let's work on A and D. Now, so that means one important thing which we have shown is that is the base angles angle D is equal to angle C, right? They are congruent or equal. Okay. Now, so that is one part. Now from here, we also note that these two are parallel sides. These are interior angles, right? So angle A is basically equal to 180 minus angle D. It is because the sum of interior angles between the parallel, you form a C, right? So that is from the properties of parallel lines, right? And transverse line. So when you get this C structure, then what you get is 180 degrees. But angle D is equal to angle C. So therefore, we can write angle A is equal to 180 degrees minus angle C, since angle D and C are same. But on the other hand, we also have a parallel line, and angle B is basically equal to 180 degrees minus angle C, right? So from these two statements, we can say that angle A is equal to angle B. So we have shown that the base angles of an isosceles trapezoid are congruent, right? So the first part has been done. Now, the second part is diagonals of an isosceles trapezoid are congruent, right? So I think we have space here. We can actually finish it off. Let me divide this page. So when we say diagonals, we mean A, B to D and A to C, right? So we now need to prove that AC is congruent to DB. Now this can be easily done, especially after we have shown that the base angles are congruent, right? So what we have already shown is that the angle ADC is equal to the angle BCD, right? And from here we know DC is equal to DC, right? This side. And we are given that AD is congruent to BC. Correct? So from this, which is SAS, we can say that the triangle ACD is congruent to triangle. So ACD is congruent to BDC. So when you have these congruent triangles, so the result is that all angles are same and all sides are equal, correct? So now that means that AD is congruent to, AC, let's rewrite. So AC is congruent to DB. So that is how we can also show that the diagonals of isosceles trapezoid are congruent. So if you are given isosceles trapezoid, you can actually go ahead with all the questions taking these two as same angles, those two as same angles, diagonals of equal length, right? So that will help you answer many questions. And my idea of taking this question here was only to help you out for such cases rather than proof for geometry. Okay, so I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.